Greetings everyone. We are Team Nexus and this video is to showcase our solution, NexusSentinel. NexusSentinel is a real-time parking violation intelligence and patrol deployment platform built entirely on actual Bangalore traffic police data. Patrol deployment in Bangalore today is largely reactive. Officers go where they have always gone. By the time they arrive, the congestion has already formed. Nexus Sentinel closes that gap. It's not just a better report, it's a perspective decision engine that tells a shift commander exactly where to send officers given exactly how many they have. We started with a record of over 3 lakh violations, aggressively cleaned it, and surfaced the main types of violations which can cause traffic and congestion issues. Coming on to our intelligence and physics. All the records render in the browser at 60 fps by .gl over WebGL. The density blobs show exactly where violations cluster. The user can also modify the filters to visualize exactly what they want. Coming on to our congestion risk. Raw density isn't actionable. So every coordinate maps into a Uber's H3 spatial indexing system at resolution 9. Switching to the congestion risk layer, you can see how this eliminates noise and makes cluster to cluster comparison mathematically clean. Click on any cluster and you get its intelligence proof. But here is where the traffic physics happens. We pull real road geometry live from OpenStreetMap, calculate the capacity loss to illegal parking, and run it through a standard traffic engineering BPR exponential delay curve. Crucially, we cross-validate these mathematical delay estimates against real-time speed data from TomTom's traffic flow API to ensure ground truth accuracy. This creates our congestion pressure index, the CPI. Every metric in this pop-up carries an evidence badge, so Commander knows exactly how it was calculated. Layer 3 shift from descriptive to predictive. You are looking at a 7-day forecast for all 54 station zones. The color intensity maps directly to the priority. Our AI is a two-stage ensemble. Meta's profit model first captures the macro temporal structure, weekly seasonality, and Indian public holidays. Then a Microsoft Light GBM gradient booster learns the residuals using features like CPI score, junction type, and recent lags. We validate this using rigorous expanding window cross-validation training on November to February, then sliding to first week of March, then second, and so on, evaluating iteratively. If the AI can't beat a basic seasonal naive baseline, the system automatically falls back to the baseline. We never deploy a model we can't mathematically justify. Let me come to the analytics board. Let's look at the proof first. The backtest view is an out-of-sample test trained purely on November through February, predicting March and April completely blind. The solid line is the real violations and the dotted is the predicted. While the backtest proves our accuracy, the final 7-day deployment forecast you see in the app is trained at the full dataset right up to date. Because of our static mathematical gate, the AI models we actually deploy into production, like in the critical high volume zones, achieve a MASE score of 0.82, significantly outperforming the baselines. Coming on to the perspective layer, the deployment grid is a 7 by 24 shift probability matrix per station. Rolling convolution algorithm sweeps across these 168 hours to find the optimal continuous patrol windows automatically. Next is our deployment layer. This is the real engine. A deploy tab. A shift commander enters their absolute constraints, let's say They have 12 officers and they want to deploy them at 7 p.m. Officer has to just click optimize. The backend instantly formulates a linear programming problem using the pulp library and CBC solver. It maximizes expected violations caught, weighted by the BPR congestion impact, strictly under that officer cap. Out comes a ranked deployment list, where every hotspot deployment card dramatically logs the exact 4-hour patrol window you just assigned. And critically, if a constraint are mathematically infeasible, it alerts the commander. For every suggestion, you can clearly see the violations caused and the impact that the officer will have, and a score. Let me walk you through the system architecture. Under the hood, fast API backend with a custom in-process cage drops repeated query latency from 1200 milliseconds to under 15. The pipeline uses pandas and numpy for ETL, H3 for sample grouping, profet and light BGM for the AI, and pulp-p for optimizer. We cross-validate traffic speeds against TomTom's Flow API. The frontend is built on React 18, White, TypeScript, and DeckGL. Looking ahead, the architecture is built for real-time scale. Right now, we are predicting just 7 days ahead using historical data, but we can easily extend that forecast window further. NexusSentinel is explicitly engineered to be effortlessly integratable with the CCTV or BPT traffic API streams. By feeding real-time violation data back into the model, the system will actively learn and significantly increase its accuracy over time, dramatically recalibrating hour by hour to capture unexpected anonymous like flash congestions or sudden closures. Nexus Sentient takes real enforcement records and transforms them into spatial clusters, exponential physics-based risk scores, validation forecasts, and a live deployment optimizer. It gives a shift commander a ranked mathematically constrained patrol plan for any hour of the day. The system is fully built, hosted, and live. Thank you very much.